already passed out the notes if you want to grab it. One back here, the green one. All right, so here is our schedule for the next week. Today, we're on that pep rally schedule. We are going over quadratic applications. We're going to look a little bit more at completing the square, which we talked about in yesterday's lesson. If you did not watch yesterday's lesson and take your notes, this link takes you to the video of the lesson. Remember, I was out. There was a sub in here. I handed out the outline Wednesday, so some of y'all maybe watched that video Wednesday night from home. What I did realize when I finally had a chance yesterday afternoon to get online and check my email and stuff, I had some messages from students that said the Delta Math was not active yesterday morning. So I did activate it. That was my fault. I apologize. So it was activated yesterday afternoon. So if you have not started it, you'll be able to start it today or work it this weekend. And I'm giving y'all an extra day since it was activated a few hours late. So that Delta Math over the completing the square from yesterday is not due until Tuesday now instead of Monday. So you've got an extra day to do that Delta Math from yesterday. But since there was no new Delta Math yesterday when you got your class time to work, hopefully if you were behind on anything, you were able to use that time to get caught up. Let's wait for these announcements. I'm not sure. I think it's just the last like fall sports pep rally. Okay, so like I was saying, hopefully you were able to use that time to get caught up with any incomplete or past Delta Maths. And then just as a reminder, the Unit 4, that's the last test we took. It's been 2 weeks now. That review, the Unit 4 review, is still available in Aware. If you still have a 0 for that review, you can still go get it done. I'm going to try and get those grades updated. I updated grades on Monday, but I'm going to try and get them updated again today if I have time. And then the Unit 5 review, that's the test that we're taking next Wednesday. That's our current unit, 5A. Okay, that review is open in Aware. Okay, so the Unit 4 review is open and Aware. You can get started on that today, work on it this weekend. If you do just a handful of problems a day, it's not like you have to sit down and do the entire review at once. But the review is the best way to prepare for the test. I don't know how else to emphasize that. It is a grade in and of itself. So one, you don't want another 0. So do the review to get that grade. And remember, you can submit it and you can make note of which problems you missed because you can immediately see your results and which problems you got wrong. So you can make a little note, okay, I missed 3, 7, and 12 or whatever. Okay, ask me to reopen it. I'll reopen it and you can go back and try those problems again. And if you don't know what to do, ask, okay, ask questions. And then you can resubmit the review. And you can do that as many times as you want until you're happy with that review grade. 1, you're going to get a good review grade. And 2, that's the best way to prepare for the test because the review is in Aware just like the test is. So it's the same formatting and style of questions so that you're used to anything that's not just like straight multiple choice. Some of those interactive question types or the wording, it's all in the review. So it's not going to be a surprise on the test if you do the review. Okay. So I would highly recommend you work on that review and get as much of it done as you could by, say, before class Tuesday. And even if you're not done, maybe submit what you have done so you can see if you've missed any that you've done so far, and then ask me to reopen it. And you at least know the ones that you've tried so far if they're right or wrong. And then I'll reopen it and you can fix those and finish the rest. Okay, or if you are able to get your complete first attempt done, then you can reopen it and you have Tuesday in class to review and ask whatever questions you have about it, and we can go over any of that. Okay. And then your test is Wednesday. Notice it does say 5A because Unit 5 is being split due to Thanksgiving break. So we're going to test over what we've learned so far in Unit 5. Okay, and then when we come back from Thanksgiving, we'll finish up Unit 5 and we'll take a 5B test before the end of the semester. Any questions at this point? Okay. Let's take a look then at the notes for today. They'll open. Go over here. All right. So this is the last set of notes for 5A. We talked about completing the square yesterday. Actually, we talked about completing the square. We learned the process of completing the square a few weeks ago. But now we're taking it a step further. And once we complete the square, we're then using that to solve for x and get our solution or our x-intercept. Okay, so let's review a couple of those completing the square style problems. All right, so we've got a quadratic set equal to 0. To complete the square, you want your constant, that's the number without the variable, on the other side of the equation. So they've already done that by subtracting the 8. Okay, and then you have your plus blank on both sides to keep it balanced. So we're at the step here where we're trying to figure out what's going to go in this blank to create a perfect square trinomial. And remember, it's b divided by 2 squared. Okay, and what is the b value here? If you don't remember these equations, when we're completing the square, they're starting out in ax squared plus bx plus c form. Okay, so what is the b here? The 14 is the b. Okay, so 14 divided by 2 squared. So that's 7 squared. Now you can write 7 squared in the blank, or I think it's better to just go ahead and square it. So that's 49 that we're adding to both sides. Okay, now the whole point of that is now this trinomial can be factored into a binomial squared. Okay, the whole point is that it would come out to the same binomial twice. If you think about our factoring that we've been doing, the x method, it's like what multiplies to 49 but adds to 14? What is it? Yeah, that's the whole point of this. It's the b divided by 2 that we came up with here. It's that 7. Okay, so we created this perfect square trinomial where it would be the same number. It'd be 7 and 7. So we just write x plus 7 once and mark it as squared instead of writing it out twice. And then we condense or simplify, combine like terms, however you want to think of that on the right. So that is 41. So that is the completing the square process. Okay, that's what we did a few weeks ago. I guess that was in Unit 4, okay, completing the square. But now in this unit, we're using that process to solve for x. Because when we had 2 x terms, we had an x squared and an x, we couldn't just isolate x because there were 2 x terms. But the way that I've got it rewritten now, there's only one x term. So I can solve this for x. So if you are asked simply to complete the square, you would stop there. Okay, but if you're asked to solve, now we're going to take this expression, x plus 7 squared, okay, it's set equal to 41, and we're going to isolate the x. So we said the opposite of squaring is square rooting. So we square root both sides, and we don't forget our plus and minus. So the square and square root eliminate, and I'm left with x plus 7 equals the positive or negative square root of 41. And notice I'm leaving that because 41 is not a perfect square, is it? If I tried to take the square root of that, I get an ugly decimal, an irrational number that I don't want. So I'm going to leave it as a radical, and then I'm going to move that 7 over. To move that 7, what does it become on the other side? It becomes -7. So you have -7 plus or minus the square root of 41. And you can leave your answer written like this with the plus or minus in it, or you can separate it and write two answers. You can write -7 plus root 41 and -7 minus root 41. But you can also just leave it with the plus or minus. That indicates that there's two solutions here. Now, I'm going to one last time reiterate to you that you can check all of these, whether you're solving by factoring or you're solving by completing the square. You can check all of them with what? How have I told you y'all can check all of your answers, all of your solutions? Desmos. Okay, this is the way the equation was originally given, x squared plus 14x plus 8. Okay, I graph that. Here's the graph, and I get these solutions. You do have to understand that solutions are x-intercepts. So where does this graph cross the x-axis? Okay, now the values we got -7 plus root 41, and we got -7 minus root 41. I have to write it separately to see what the two separate decimals come out to. But doesn't that match the graph? It does. So that means we did it correctly. All right. Now, some of the questions may not be just straight, what's the solution? So you can't just come and give a decimal answer. It may be like, what is the completing, when you complete the square, what is this format? Maybe it'll ask you to stop here because it's checking, do you actually know the process? So we do need to know the process, but it's important to also know you can check the final answers in Desmos. If it's simply asking for that final answer, that solution, that x-intercept, you can just look at the graph in Desmos. All right, on number 2, it says Greg correctly solved the equation by completing the square. Which equation is part of his solution? So it's not asking for the final answer. They're saying which one of these would have been a step in his process. So we're going to do it ourselves and see what matches. So we are to the point where the constant is already on the right side. So we're ready to add our constant that would make that the perfect square trinomial. Okay, we're completing this perfect square. So to get what goes in that blank, that's what we just did up above. It's b divided by 2 squared. And in this case, our b is 6. So that is 3 squared, which is 9. Okay, so we are adding 9 to both sides. And then to simplify, on the right side, that simplifies down to -1, which that narrows it down. I've only got 2 choices that have a -1 over there. Okay, so what should be in this binomial? Should it be +3 or +6? What goes here? It's either this +3 or this +6. It's the 3. Remember, it's half of b. B was 6. B is not what goes here. Half of B is what goes here. Okay, so you do need to remember that. So this is the one that has that correct. So it was answer choice B. And this one had the wrong value there. All right, this one shows Kylie's first step in solving by completing the square. And they just want to know what's the next step. Okay, so here she was given this trinomial equal to 0, and we can see that she added +7 to both sides, and then she simplified that. So she's got x squared minus 10x equals 7. So the next step, once you've moved the constant to the other side, is to come up with that plus blank. So you can see all the answer choices have plus blank. We just have to figure out which one of these was the right number to go in that blank. How do I figure out what goes in that blank? What did I do on those first two examples? Half of b divided, or excuse me, half of b squared, right? So b divided by 2 squared. So what is the b in this equation? And negative 10 right here. So negative 10 divided by 2 squared. Okay. Half of b was 5, but that's not what goes in that blank. It's half of b squared that goes in this blank. So pay attention to what step it is that you're looking for, okay, and be careful with selecting your answers. Good? So some of the wrong answer choices here, notice here they doubled b. Here they squared b. Here they divided b by 2. But we were supposed to divide by 2 and square. Okay, so just make sure you understand it's b divided by 2 squared. B divided by 2 squared. All right, so that's completing the square. Now let's think back to what we were talking about before completing the square. Let's apply some of what we've learned. Okay, we did factoring. And once we got our quadratic factored, we did the split and solve step. Does that sound familiar? Split and solve. I've said that a bunch. You take each individual factor, set it equal to 0, and solve. And those are your solutions. And I talked about how if your factor is just x plus or minus a number, your solution is just going to be the opposite sign of that. Whoever's phone is making noise, turn it off. So if they're giving, this is just going backward. Instead of asking us to find the roots and us factoring to do that, they're giving us the roots and asking us to write the equation. So if our graph crosses the x-axis at -2 and +3, now I don't know anything else about this. Maybe it's opening up, maybe it's opening down. I don't know. But a generic sketch there, this is what they're telling us. It crosses at -2 and 3. Those are the roots. What could the factors be? Because it would be, there's 2 roots, so there's 2 factors being multiplied, set equal to 0. Okay, so for a root at 3, what would the factor be? We're going backward from what we've been talking about. So if you need to think back, let me pull up our factoring notes from a couple days ago. So here, like any of these examples is fine. When you get the factor and then you set it equal to 0 and solve to get the solution, what do you notice about the root and the factor? It's the opposite sign, right? If the root is -1, it was x plus 1. Here, the root was 2, it was x minus 2. Here, when the root was 1, it was x minus 1 for the factor. Remember how, I mentioned that, I pointed that out. I said, whatever your factor is, if it's just x plus or minus a number, it's just the opposite sign, that's the root. Okay, so let's go back to today's. If the root is at 3, the factor would have been x minus 3. If the factor is negative, or excuse me, if the root is -2, the factor would be x plus 2. You're just changing that sign. Because now if I set this equal to 0 and solved, isn't 3 what would make this 0? 3 minus 3 would make this 0. So the solution is 3. Okay, if I plugged this -2 in here, it would make this 0. The solution is -2. Y'all get that? So what would it be for number 5? If the roots are -5 and -1, what would the factors be? The root is -5, so the factor should be x plus 5. Remember, it's going to be the opposite. And if the root is -1, the factor should be x plus 1. You feel okay about those? Just have to know to change the sign. Okay, what if we just want to figure out which one of these equations has only one root? Because remember, the possibilities for quadratic roots, a quadratic is a parabola. So it could look like this and have 2 roots. It could look like this and have 1 root, meaning the root is the vertex, right? Or it could look like this and have 0 roots. It doesn't cross the x-axis. There's no real roots there. Okay, so we could have 0 real roots, 1 real root, 2 real roots. Okay, and they're asking which of these equations has only 1. So we're going to have to factor this to figure it out. If there's only 1 root, that means there's only 1 factor. So let's factor these. For A, when I do my X method, I'm looking for what multiplies to 6, but adds to -5. So what multiplies to 6, but adds to -5? Factors of x squared or x. First of all, the fact that it multiplies to a positive but adds to a negative, what do I immediately know? If it multiplies to a positive, they have to be the same sign, right? Either both positive or both negative. Okay, and if it adds to a negative, that means they both must be negative. So what 2 negative numbers multiply to 6 but add to 5? 3 and 2. So -3 and -2. If I multiplied those, I would get +6. If I added them, I'd get -5. That's 2 different roots, isn't it? The question's asking which one has only 1 root. It's not A. There's 2 roots there. Let's try B. For B, looking for what multiplies to +4, but adds to -4. Again, multiplies to a positive, but adds to a negative. I immediately know they must both be negative. Yeah, it's 2 and 2. -2 times -2 would give me +4, and -2 plus -2 would give me -4. So initially that looks like 2 factors, but aren't they identical? Yeah, and we said in yesterday's notes, I'll pull them back up, or this is 2 days ago, I think. We said when you get the same root twice, that's called a repeated root. You don't need to solve it twice. It's only 1 root. Okay. And I told you that that indicates when that happens, when there's a repeated root, like in those examples, that means that the graph touches the x-axis at that root instead of crossing. So what's happening there is like this image that I sketched. It's coming and touching, but not crossing because it's the vertex there. So there's only 1 root because it doesn't cross and then cross again. It just comes and touches and turns around. So that one has only 1 root, has a repeated root, but there's only 1. Now you can confirm just that C does not have 1 root by factoring. We'll just double check here. What multiplies to -20 but adds to -1? The fact that it multiplies to a negative tells me I need one positive and one negative. What multiplies to 20 but has a difference of 1? 20 and 1, 10 and 2, 5 and 4. Any of those? 5 and 4 have a difference of 1. So -5 and +4 would add to -1. That's two different roots. So again, A and C are out because they had two roots. So the only one that had only one root was answer choice B. It had one repeated root. That makes sense? Okay, so your practice in Delta Math, let me just pull it up here. You've got 3 under the upcoming tab, possibly, if you haven't already finished these. So today's is the 15th, the quadratic applications. These questions are very similar to what we were just doing in the notes. Now, I do want to tell you, let me clarify. These are questions, see, it just has numbers in them. It doesn't describe the question because they're not from the Delta Math bank of questions. They were typed in by one of our other Algebra 2 teachers. So if you get it wrong, it's not one that keeps cycling and just giving you new attempts with different problems. If you get it wrong, it's wrong and you lose the points. But they are set to 3 attempts. So for each question, you get 3 tries. So if you get it wrong, it tells you, sorry, that's wrong. Try again, go back, try to fix it. Okay. If you get it wrong a second time, you should probably be asking questions before you submit that third attempt, because if you get that third one wrong still, then it's wrong for good and you lose the points. Does everybody understand that? Okay, I know we've had some questions like that before, but this whole assignment is like that. There are no questions here from the database of Delta Math. So there's no generating new problems to try again. Okay, once you get the question wrong, it's wrong. Okay. It's keeping the formatting that we saw in those notes too. But if you have a question after getting one wrong, if you want to double check your formatting, definitely ask questions. That's not due till Tuesday. Okay, the one from yesterday, as I mentioned, I know I didn't get it. It was a couple hours late getting activated. So I pushed it to Tuesday as well. So both of those are not due till Tuesday. And then this is the one from the 13th. That's from Wednesday. Okay, that is due Sunday night. Okay, it would have been due today, but it's Friday, so I give you the weekend. So you've got the rest of the weekend to finish that one up if needed. Hopefully you were able to get some of these completed yesterday or this one, the late one's done, since the new one wasn't there. Hopefully you use that time to get caught up. And then just as a reminder, anything under the past due tab, late credit available. If it's from the current unit, it's going to be at 75% credit until the test day next Wednesday. Okay, and then it's going to drop to 50% credit. Anything from a previous unit is already at 50% credit, like these down here. Okay, and everything is going to stay open for late credit until December 12th. Okay, that's what I'm going to start finalizing grades for this semester for the 9 weeks. So I'm leaving everything open until December 12th for late credit. Okay, y'all got the rest of class to work on that. Okay.